Hi, I'm Tom Beebekauser with Wetland Restoration and Training. I would like to show you the Slabcamp Creek Stream and Wetland Restoration Project today. This project was designed by Dr. Art Parola and is located on the Daniel Boone National Forest in eastern Kentucky. And Dr. Parola had some really innovative techniques that he used on the ground here. One was to remove 4 foot of historic alluvium that had collected in the valley from historic management practices. Another technique involved using the trees and the logs on site to provide vertical grade control and to control erosion. And what the amazing part about this project is that this intermittent stream is now perennial, and that's really good news for the fish. So the techniques that he used really worked. The beaver have moved in since the restoration was completed in 2011, and they've even added to the diversity of the wetland and the stream on this property. So let's get going and let's explore this restored stream.
Slabcamp Creek is located in Rowan County, Kentucky, within the Daniel Boone National Forest. The stream is in the Licking River Basin and the mountain bioregion of eastern Kentucky. Slabcamp Creek is in a narrow valley that's heavily forested with oak and hickory trees. This aerial photo shows the level ground along Slabcamp Creek being farmed in 1950. The dark staining shows the fields were wet and the ditches were filled with water. This piece of barbed wire in a dead tree shows that fences had been strung to keep livestock out of the agricultural fields along Slabcamp Creek. The private land and the fields in the valley were acquired by the U.S. Forest Service for the Daniel Boone National Forest. Slabcamp Creek was historically channeled and moved to the base of the mountain to create long and narrow agricultural fields. The stream, along with its tributaries, were also moved and channeled to create dry land for building homes and barns. Slabcamp Creek and its tributaries would dry in the summer and fall. Ditches were dug by hand, with clay tiles being buried in the bottom of these ditches to drain the wetlands. These ditches that meet at right angles show where a wetland was drained years ago on the floodplain of Slabcamp Creek. Drains were made of wood to dry the wetlands along Slabcamp Creek, and rock drains were built to drain the wetlands. This illustration from an early drainage book shows how farmers were using both rock and wood drains to eliminate wetlands. The surface of this ground was shaped into lands with dead furrows so a wetland could be farmed. This is tobacco that's being grown in a field that was made by draining a wetland along Slabcamp Creek. Years ago, a railroad track was installed along the moved and channeled Slabcamp Creek to transport logs to a sawmill. The historic access for people living along Slabcamp Creek was to ride their horses and pull their wagons in the ditched and straightened stream. I've heard from seniors that streams like Slabcamp Creek with its rock and gravel channel were used as roads in the narrow hollows of eastern Kentucky. When automobiles came on the scene, Rowan County maintained Slabcamp Creek as a road. After the land was purchased by the government, the Forest Service planted pine trees in the fields. The planted trees did nothing to stop the erosion that began when the streams were moved. When I first visited Slabcamp Creek in the late 1980s with fisheries biologists, we thought it was natural for streams like Slabcamp Creek to be straight and flow over bedrock. We didn't know anything about head cuts or why these streams were flowing along the base of the mountain instead of being in the center of the valley where the ground was lower. In talking to residents whose grandparents farmed the fields along Slabcamp Creek and nearby Stonecoal Branch, we learned that the valleys were once wetland. The streams were so narrow you could jump over them. They said that during a flood, the streams would flow out of their banks and cover the floodplain. This didn't happen anymore. A former resident described to me how his grandfather dug a ditch along the base of the mountain to divert Stonecoal Creek to make agricultural fields. Walking along Slabcamp Creek, you could see the stream flowing over bedrock with very few pools and riffles. This was because the channeled stream had eroded through the soil and the gravel in the valley. Head cuts were common in Slabcamp Creek and its tributaries. These head cuts were so eroded that they cut through the bedrock as they moved upstream. The streams cut so deep, water no longer flowed over the banks and across the valley in a flood. There were few pools and riffles because the stream was flowing over bedrock. Large trees had fallen into the moved stream because the banks were eroding. The downcutting of Slabcamp Creek was causing severe bank erosion. Portions of the stream banks were sliding downhill into the stream channel. The U.S. Forest Service purchased an easement from a private landowner on May 2, 1986. This was so a road could be built along Slabcamp Creek to provide access for a timber sale on National Forest System land. The Forest Service moved the Slabcamp Creek Road out of the stream channel and up onto the floodplain. Following the timber sale, where most of the planted white pine were harvested, I began helping the Kentucky Department of Fish and Wildlife Resources to stock trout in Slabcamp Creek. This was an annual event involving the Scouts and Trout Unlimited, where we placed the trout in plastic bags, added oxygen, and then carried the fish up Slabcamp Creek and Stonecoal Branch. In many years, we had trouble finding pools of water to release the trout because the stream had dried. A big project we did in 1989 and 1990 was to build structures in Slabcamp Creek and Stonecoal Branch, and this was to control erosion and to create pools for trout. We followed the guidance and designs shown in the Forest Service Fish Habitat Improvement Handbook. It was very embarrassing to find that these structures that took us days to build washed out within a few weeks after construction. We returned to replace these structures, which some are now calling beaver dam analogs or BDAs. This time we used a backhoe to anchor the logs into the banks and lots of wire and rebar stakes to hold the logs and branches in place. Again, the structures washed out following spring rainfall. The failure of the BDAs caused even more stream bank erosion. There were no signs the stream would ever heal on its own. On one field trip with Monty Seahorn, a fisheries biologist with the Forest Service, he recommended using explosives to create pools in the bedrock of Slabcamp Creek and Stonecoal Branch. We didn't do this. In the early 2000s, Dr. Arthur Parola Jr., director of the University of Louisville Stream Institute, told me about a new Kentucky Department of Fish and Wildlife Resources fee in lieu of mitigation program for stream and wetland restoration. I soon invited Dr. Art Parola, U.S. Forest Service hydrologist John Walker, and others to walk Slabcamp Creek and Stonecoal Branch with me to see if the streams might qualify for the program. Everyone agreed we are seeing excellent potential for restoration of an entire valley, including its streams, its wetlands, and forests. The project would control erosion and greatly improve habitat for fish and wildlife. However, there were two major obstacles we would have to overcome. The first one was that no mitigation project had ever been done to date on National Forest System land. The second major concern was that many trees would have to be felled in riparian areas to complete the project. My supervisor with the U.S. Forest Service was District Ranger James David Manor, who had previously served as a wildlife biologist. The restoration of Slabcamp Creek and Stonecoal Branch would not have been possible without Dave's leadership and support. At the time, a few individuals within the Forest Service, they were attempting to prevent the project from proceeding by insisting that an environmental impact statement, or EIS, be completed under NEPA, the National Environmental Policy Act. This move would have effectively ended the program. In August of 2006, Dave Manor approved a decision memo that authorized the restoration of Slabcamp Creek and Stonecoal Branch. His decision allowed the project to move forward. This would be the first stream mitigation project completed on National Forest System lands within the United States. The design, construction, monitoring, and maintenance of the Slabcamp Creek and Stonecoal Branch Restoration Project was funded by the Kentucky Department of Fish and Wildlife Resources Fee in lieu of Mitigation Program for Stream Restoration. The mitigation plan that was required by the U.S. Army Corps of Engineers for the project was prepared by Benjamin D. Mader, Arthur C. Parola Jr., Ph.D., and Chandra Hansen with the University of Louisville Stream Institute. They completed the plan on October 2nd, 2009. The mitigation plan was for the restoration of second-order intermittent and first-order ephemeral streams on the Daniel Boone National Forest in southeast Rowan County, Kentucky. The drainage area of Slabcamp Creek at the upstream limit of the restoration area was 83 acres. At the downstream limit was 563 acres. Within the site boundaries, 7 tributaries flowed into Slabcamp Creek. These tributaries each drained between 32 and 192 acres. The University of Louisville Stream Institute began monitoring stream flow and temperatures in Slabcamp Creek and nearby Stonecoal Branch. Here, William Vesley, research project engineer with the University Louisville Stream Institute, is installing open-bottom buckets that contain sacks that can be removed to monitor sediment movement in the stream. Feed bags placed in the buckets captured soil and rock that was moving downstream in flood events. The bags are periodically removed and the contents weighed and measured. Look at how wide the stream channel is in this photo and the lack of aquatic plants that are growing in the channel and on the floodplain. The Stream Institute used a 2D model based on extensive data collection to design a meandering floodplain that was from 30 to 50 feet wide. This table in the mitigation plan lists some of the proposed channel characteristics and classification for Slabcamp Creek and Stonecoal Branch. Important points to note are that the 100-year discharge of Slabcamp Creek is from 130 to 500 cubic feet per second. The design stream channel slope would vary from 1.08 to 3.8%. The designed valley slope would vary from 1.08 to 3.1%. The flood-prone width would be up to 90 feet wide, and the bankful width would be 13 feet or greater. This drawing shows how the moved and ditched stream had lowered the elevation of groundwater in the valley. The elevation of groundwater could be expected to rise after the ditches were filled for this project. Deep test holes were dug using an excavator in December 2008 as part of the design process. The deep test holes showed from 1 to 4 feet of silt loam and sandy loam texture soil on the surface. The fine textured soil near the surface was not saturated. We uncovered gravel and cobbles mixed with sand from 4 to 13 feet thick that overlaid bedrock. We plan to use the buried gravel and cobbles in the stream restoration. The gravel was saturated. Groundwater filled the hole and rose to the top of the gravel. Here, groundwater is visible in the pit that was created by this tree falling over on the floodplain. There were chunks of wood, branches, and decomposed leaves in the test holes, and this indicated relic wetlands had been covered by sediment deposition. The sediment came from logging and from farming the hillsides. The overlying soil was likely to have been eroded from adjacent hillsides and ridgetops because of past grazing, cultivation, and logging practices. Here you can see groundwater entering the test hole. The groundwater was in the sand and gravel, and this was below the well-drained soil on the surface. This would be a pioneering project in that the thick layer of historic alluvium on the surface would be removed to expose the gravel that was saturated with groundwater. This was the opposite of what engineers were doing at the same time without success in trying to perch streams on top of well-drained soil. This drawing shows the valley before restoration. The ditch stream was separated from the groundwater when it was moved into a ditch on higher ground along the base of the mountain. Here's how the valley would appear after restoration. The restored stream would be near the center of the valley and would be reconnected with groundwater. Slabcamp Creek and its tributaries would be restored so they were reconnected to groundwater. Construction took place in 2010 and 2011. Construction was supervised by engineers and engineering students with the University of Louisville Stream Institute. Ferris Osborne and his brother Mike Osborne with Advanced Enterprises were the contractors and the heavy equipment operators that helped complete the project. Sections of Slabcamp Creek where water was flowing in the channel that had been historically moved to the base of the mountain, these were left open during construction. This was done to help keep the construction area dry and to keep soil that was moved with heavy equipment from entering the stream. Where the stream was flowing in a ditch near the center of the valley, it was moved into a temporary ditch that we dug along the base of the hill. These temporary ditches reduced the number of pump-arounds that were needed for the stream restoration project. The temporary diversion of Slabcamp Creek along the base of the hill was the most controversial part of construction for the project. This is because of how muddy the water would appear in the ditch following a heavy rain. Here the diversion ditch is keeping the floodplain dry under construction. The contractors are also driving into the work area along the dry ridge of soil that's located along the edge of the ditch. Soil was not being washed downstream because of the many wetlands that we had dug along the length of the ditch to serve as sediment basins. It was necessary to remove the trees growing in the old fields to complete the stream restoration project. The felled trees were temporarily placed along the base of the hill so they could be picked up and placed by the excavator on the restored floodplain and stream channel. Ferris Osborne and Mike Osborne are using the excavators to remove from 1 to 4 foot of a historic alluvium to restore the channel and the floodplain for Slabcamp Creek. The excavators are placing the soil along the base of the hill where it will be shaped and planted to appear natural. The silt loam and sandy loam texture soil that washed off the hillsides is being removed to expose the natural gravel, cobble, and groundwater that are beneath. An engineer is on site every day, and every hour the heavy equipment operators are working to monitor elevations and to make adjustments as needed. The floodplain is made wide and level in cross-section so water will spread out in a sheet-like pattern and not cause erosion. Notice how groundwater is seeping out of the gravel, overlaying the shale bedrock. Groundwater begins rising to the surface as the excavator removes the historic alluvium. Groundwater quickly rose to the surface of the restored floodplain once the historic alluvium was removed. Large diameter trees are placed and buried across the excavated channel and floodplain, and this is done to prevent head cuts from forming that would cause erosion and lower the elevation of groundwater. The excavator begins by digging a narrow trench at right angles across the stream channel and the floodplain that are being restored. The trench is dug so that when the tree is placed in the trench, the top of the log will be at the planned elevation. A hole is dug at one end for the root mass to be set in the ground. A long, large diameter tree is moved into the trench. Here the tree is being placed into the trench. The entire length of the tree is pushed into the ground using the bucket and the tracks on the excavator. The bucket on the excavator is used to pound the tree into the ground. A reading is taken to make sure the top of the log is at the planned elevation. We're now ready to place and compact soil around the log so water won't flow under the log. Soil, gravel, and cobbles are placed on either side of the log. The bucket of the excavator is used to compact the soil on both sides of the log. The top of the log in the stream channel is not covered with soil. The bucket on the excavator is being used to expose the very top of the log where it crosses the stream channel. This drawing is a typical profile view of a grade log placed across the width of the stream channel and the floodplain of a restored stream. Over 90% of the log is buried, and there's no more than a 4-inch change in elevation from the top of this log to the top of the closest log upstream or downstream. Here's where a splash log has been added to reduce the chance of water flowing under the grade control log. Splash logs should be used where the soil is high in organics or sand and the slope is greater than 1%. This drawing shows a typical plan view of the placement of grade logs for a stream restoration project. The distance between the logs depends on the percent slope, the soil texture, and the diameter of the logs being used. Many of the felled trees are also placed in the channel and on the floodplain to improve habitat for fish and wildlife. These trees placed for fish and wildlife habitat are all different diameters and lengths. They're not purposely embedded into the ground or set to any specific elevation for grade control. An abundance of large wood is placed on the floodplain. The logs are placed so they will appear natural on the restored floodplain with no chainsaw cuts being visible. Some of the sections of the logs that are placed to provide habitat are covered with soil. Look at the natural appearance and complexity of this restored valley of Slabcamp Creek. The excavator operator placed snags of different lengths and diameters on the restored floodplain. Snags of all different sizes were placed in the stream channel and on the floodplain. Small wetlands were excavated on the restored floodplain that filled with surface water and with groundwater. Many small wetland pools were built along the restored stream channel. This small wetland was restored by blocking a ditch. We built this wetland by blocking a small tributary in a ditch. Here's where we excavated a wetland pool around a boulder. This small wetland was built from a short section of diversion ditch. All ground surfaces were prepared for seeding and planting by using the rough and loosen technique. The bucket on the excavator was used to loosen compacted soils to a depth of 3 feet. The rough and loosen technique, plus the addition of large woody debris, were also very important in controlling motor vehicle use that could have damaged the restored streams and wetlands. No rubber-tired vehicles or heavy equipment on tracks were allowed to travel to areas or through areas where soil was loosened using the rough and loosen technique. The exposed soil was seeded to wheat and mulched using wheat straw. The seed and straw were spread by hand to avoid compacting the soil that would have occurred if a tractor and a straw blower were used. One of the main reasons the project turned out so well is that one or more engineers were on site working with the heavy equipment operators every day. They were allowed to modify implementation of the design as needed without causing delays or incurring expensive change orders. The gravel and cobbles that were uncovered during construction were used for restoring the bed of the stream channel and the floodplain. A large buried vertical grade control structure was installed across the valley of Slabcamp Creek at the boundary of national forest and private land. This was built to protect the restoration project from headcuts that were moving upstream from private land. The soil removed from excavating the floodplain and stream channel were used to fill the eroding ditch along the base of the hill. Sections of the ditch were left open and reshaped to restore wetlands. Groundwater dams were built at regular intervals across the ditches being filled to prevent water from continuing to flow in the bottom of the ditches beneath the soil that was placed in the ditch. Jeffrey Lewis, U.S. Forest Service silviculturalist, took the lead in prescribing a diversity of native trees and shrubs that would be planted on the restored floodplain. Some of the planting was done by volunteers who were working with the Forest Service. They planted buttonbush, bur oak, pin oak, shoemart oak, speckled alder, swamp chestnut oak, swamp dogwood, sweet gum, white oak, willow oak, and willow. We applied big game repellent that was made from dried blood to the bare root seedlings that we were planting. The Kentucky Department of Fish and Wildlife Resources provided funding to the Forest Service to monitor vegetation in the project area. More than 160 native volunteer wetland plant species were present during the 5th growing season after the project was completed. This photo shows how the Slabcamp Creek Restoration Project appeared in 2011, the same year that construction was completed. We were amazed to find that Slabcamp Creek was flowing in October, which was at the driest time of year. This project transformed a stream with an intermittent flow to a stream with a perennial flow. The restored tributaries, which were ephemeral, were also flowing in late summer. During a flood, the water flowing in the stream didn't cause erosion. This is because it could spread out in a sheet-like pattern across the restored floodplain. The logs placed across the stream channel and floodplain were doing their job in preventing headcuts from forming. These grade control logs had also formed small pools in the stream. Small fish and an abundance of aquatic invertebrates were living in these pools. A diversity of sedges and rushes were growing along the banks and the floodplain of the restored stream. A lush and diverse wet meadow wetland habitat had developed along the entire length of the restored floodplain. The restored floodplain had developed into a large and wide ribbon of wet meadow wetland. The larger stream pools were still filled with water even in the dry fall season. The many small wetlands that were restored in the floodplain had all filled with water. The restored wetlands were teeming with a diversity of frogs, toads, and salamander larvae. I observed green frogs, gray tree frogs, spotted salamander eggs, and even otter sign in and around the many wetlands that were restored on the floodplain. We were all amazed to see the amphibian use in the restored wetlands. A diversity of native plants was growing in the restored wet meadow wetlands. These plants had not been seeded or planted for the project. It was hard to believe that this was bare ground the year before. The participants of the Slabcamp and Stonecoal Stream and Wetland Restoration Project received the U.S. Forest Service's 2010 Regional Foresters Award in Natural Resources. The team was recognized for developing low-cost and highly effective techniques for restoring streams and wetlands that can be used across the nation to reduce erosion and to improve habitat for fish and wildlife. The Kentucky Department of Fish and Wildlife Resources, University of Louisville, Advanced Enterprises Incorporated, and the U.S. Forest Service all worked together to restore over 3 miles of altered stream and associated streamside habitat along Slabcamp and Stonecoal Creeks, and this was being done to improve habitat for fish and wildlife on the Daniel Boone National Forest. Soon after the project was completed, beaver moved in and began building dams along the restored stream and its tributaries. The beaver were controlled during the 5-year monitoring period that followed construction until the project was accepted for mitigation. The arrival of beavers, along with their construction of dams and lodges and their cutting of trees, was a strong indicator that the Slabcamp Stream Restoration Project had succeeded. Their activity demonstrated that the ecosystem had regained the natural conditions necessary to support this keystone species. Unfortunately, the government agency's refusal to recognize the emergent plustron wetlands that were created by beavers as valid for mitigation purposes revealed a serious misunderstanding of how natural riparian ecosystems function when they're not degraded by drainage or farming. Beaver had changed some of the wet meadow and forested wetlands that we restored along Slabcamp Creek into open water emergent wetlands. This should have been okay because of how this type of wetland also cleans runoff, will control flooding, and provides habitat to a diversity of wildlife and fish species. These drone images show some of the beaver dams and ponds in the year 2019, which was 8 years after the project was completed. Here Jeffrey Lewis shows us a tulip poplar tree that was cut by beaver and then sprouted. Here's one of the many canals that was dug by beaver along Slabcamp Creek. I walked the restored Slabcamp Creek 2 times in 2025. I was amazed with how natural the stream and the valley appeared. There was no erosion, and there was an incredible diversity of animals and plants on the floodplain. My second visit in June was on a sweltering 98-degree Fahrenheit day with Mike Hardin and Emily Lawson, both with the Kentucky Department of Fish and Wildlife Resources. Mike was the key person with the Kentucky Department of Fish and Wildlife Resources that made the project possible 14 years ago. Emily is my daughter who's always liked exploring streams and excels at finding animals. We found the project was very successful in meeting its objectives. Intermittent and ephemeral streams had been transformed into perennial water streams. These streams, once supplied only with runoff, were now connected with groundwater. There was no erosion. Headcuts located downstream had not advanced into the project area. The gravel and cobbles in the stream channel, they were clean of sediment. The restored tributaries were free of headcuts and contained many pools and riffles. The logs that were buried across the floodplain in the stream channel, they were working as designed. Water was not flowing under or around the logs. The grade logs were functioning as planned. The water is a little muddy because we are walking upstream of the logs. This was the first stream restoration project I know of where logs were used to control erosion and to prevent headcuts from forming in the restored streams. The logs embedded for grade control had not decomposed because they were saturated all year. These logs were maintaining small pools in and along the stream channel. Logs placed to improve habitat were also working as designed. This group of logs looks like they naturally fell into the stream. Here's an example of the high-quality fish habitat that was restored by the project. The restored stream has cooler water temperatures in the summer. This is because of its connection with groundwater. This restored tributary is carrying a strong flow of water. The floodplain is supporting wet meadow wetland. The restored floodplain is a fully functioning and diverse wet meadow wetland. Dr. Amy Bracchia, professor at Eastern Kentucky University, worked with graduate student Nicholas Rivetta in 2014 to conduct research on the response of benthic macroinvertebrates to the Slabcamp Creek restoration project. The research that Nick Rivetta conducted indicated greater macroinvertebrate abundance and biomass in the restored Slabcamp Creek compared to the moved and ditched white pine branch, which was used as a control stream. For all seasons combined, Slabcamp Creek had the greatest richness of 52 taxa, with the control stream having only 45 taxa. 11 rare taxa were collected from riffles of Slabcamp Creek, while only 5 rare taxa were collected in riffles from the control white pine branch. The invertebrate taxa that make up EPT, which stands for Ephemeroptera, Plecoptera, and Trichoptera, are crucial biological indicators of stream health, and this is due to their low tolerance for pollution. The presence of EPT taxa in streams indicates good water quality, high dissolved oxygen levels, and minimal sedimentation. There was a greater abundance of EPT taxa, the scrapers, the grazers, the clingers, the slow seasonal developers, and taxa with large body size of maturity, and fast-flowing water taxa at Slabcamp Creek. Overall findings suggest that differences in macroinvertebrate communities between streams during the first post-restorational year likely resulted from improved hydrology, channel bed stability, and benthic food resources that are associated with the restoration practices at Slabcamp Creek. Changing the ditched, drained, farmed, and logged floodplain of Slabcamp Creek into a naturally appearing and functioning wet meadow wetland was a significant accomplishment. Beavers are welcome residents to the restored valley and were now okay if they cut trees in the project area. The water flowing over this beaver dam indicates that there are fewer beavers in the valley compared to a few years ago. The depth of water in the beaver ponds was lower than what I saw during an earlier visit. The mud flats along the water's edge is offering shorebirds excellent foraging habitat. The beaver dam in the foreground is no longer being maintained by beaver. The beaver pond is becoming a wet meadow wetland. It doesn't get any better than this. There's no doubt that this project is a complete success. The restored streams and wetlands in this valley are built to last for thousands of years, functioning naturally without the need for maintenance. Numerous wetlands were restored as part of the project. This wetland was restored from a section of ditch stream. This small wetland was restored on higher ground along the base of the hill. This ditch channel was transformed into a series of wetlands along the base of the mountain. You're looking at an area where soil was spread that was removed from excavating the floodplain and the channel for the stream. Here's another wetland that was built from a ditch section of Slabcamp Creek. The soil that was used to fill the section of ditch is now growing trees and shrubs. We observed many trees and shrubs that were planted 14 years ago that are growing on the soil that was spread from restoring the floodplain. Most soil disposal areas and other projects are dominated by non-native invasive plants, and this is because they did not loosen the compacted soil following construction. We used the rough and loosen technique to establish a diversity of native plants with great success. This integrated stream and wetland restoration project is showcased at US EPA Functional Assessment and Restoration Workshops. It's a leading example of successful design and implementation. The Slabcamp and Stonecoal Stream and Wetland Restoration Project is the most natural-looking valley restoration I've seen in my career. I've long wanted to show this site to anyone considering stream and wetland restoration. This is so they can see firsthand what is truly possible to achieve. I'd like to congratulate and thank Dr. Art Parola and Mike Hardin and many others who dedicated the long hours in both heat and cold to design and implement the Slabcamp and Stonecoal Stream Restoration Project. Your outstanding work has made a lasting contribution to improving habitat for fish and wildlife on the Daniel Boone National Forest.
The Slabcamp Creek Stream and Wetland Restoration Project is the best that I've seen in all of the United States. I have been up and down this valley a number of times over the years, and I can find no erosion, which is remarkable. The diversity of animals and plants that are using this restored valley is amazing. Wetlands are everywhere. When you come up here, you better wear rubber boots because the soil is saturated and the floodplain has been restored. Well, if you like this video, please let us know and please subscribe so you won't miss any future episodes. And thanks for joining us, and I wish you every success restoring wetlands and streams.